Assalamu alaikum. Today we're going to start with a new subject, which is special sensation. You know, special senses are different from general sensation that we have already studied, like touch, pressure, pain, temperature. These are called general sensations. The special sensations here, like vision, hearing, taste, smell, equilibrium. These special senses, they have their receptors located in a specialized area like vision. These receptors are confined to the eye. The receptors for hearing or audition is confined to the ears. The receptors for taste is confined to the dorsum part of the tongue and pharynx. The receptors for smell are confined to the nose. And last but not least, the receptors for equilibrium are found in the inner ear. So today we'll start with the first special sense, which is vision. Our objectives is to describe its receptors, how they work. Its receptors, they are not different from other receptors. They have the same mechanism. They are called transducers. They convert any kind of energy, which is light energy in this case, into electrical energy. To start with, we're going to talk about optics, and in optics, we're going to talk about lenses and how they work, and determine the power of the lenses because we are going to use it later on. When you say my glasses, if you are wearing glasses, is +1, +2, +0.5, whatever. Degree, you say degree, it's not a degree, it's in fact a diopter. So the unit of the power of the lenses is diopter. We're going to talk about it. We're going to talk about how we can see from near distance or far distance, some abnormalities of seeing, what was called nearsightedness and farsightedness. Nearsightedness called myopia and farsightedness hypermetropia or hypermyopia. Nearsightedness sometimes you refer to short قصر النظر وfarsightedness طول النظر. How we going to correct them? These are errors of refraction, and we're going to describe visual acuity and its abnormalities. When you say my vision is 6/6, 6/12, 6/24, what does it mean? These are called visual acuity. In fact, the American system, they say 20/20 because what we measure 6/6 in terms of meters, and when they say 20/20, they measure it in the form of feet. We're going also to talk about intraocular pressure and glaucoma. To start with, we're going to talk about the refractive index. You say when light passes from one media to another media, it refracts, بينكسر. Speed of light in air is around 300,000 kilometers per second, which is around 186,000 miles per second. It's very fast. And it is fastest in the air than in any other media. When the light goes to another media, it refracts, and the refractive index is the ratio of speed of light in air to the speed of light in that media. So you imagine that the refractive index is always 1 or more because it's 300,000 over less number. Now, light refracts, and how much refracts depend on the refractive index. The more the refractive index, the more is the degree of refraction or the angle of refraction. We're going to talk first of all about this is what you see is The light rays coming from air, when it goes down in the water, its speed is different, so there is a refraction. Here also there is a fraction of the light that's coming from any object when it goes through into the retina. So here the far object and here near object, how both of them see it's either far object or near object, their picture has to be on exactly on the retina to see it clearly. Now this is, to start with, we're going to talk about the structure of the eye. The eyeball consists of three layers. The outermost layer is called sclera. This is the sclera here. And it surrounds 4/5 of the eyeball. Anteriorly, the sclera here continues as the cornea. And the cornea here is very transparent, avascular. And the sclera is a very dense connective tissue layer. It looks like quite lately here. Now, so this is the uppermost layer, the outermost layer, I mean. And the cornea we call cornea, sclera sulbae. This cornea is avascular, and if it is avascular, it means it is not exposed to the immune system, which means it does not have antigenic activity. So you can transplant corneas from any person to any other persons without the problem of rejection like any other tissue. The middle layer here is called choroid. The choroid is the vascular layer of the eye, vascular. And the choroid continues anteriorly as a ciliary body here, ciliary body, cilia muscles, that continues also anterior as the iris. The iris, which is the colored part of the eye. In between the iris here is the pupil. Now, from the ciliary body, there are ligaments. These are the ligaments. The ligaments are connected to the capsule of the lens. The lens is found in the capsule. The lens, in fact, is multi-layers of proteins. These are very transparent, and you know the protein, like the protein of the egg, or بياض protein. This is fluid-like structure. So this can be pressed or can be less compressed, depends on the capsule around it. If the capsule is tight, it's going to press it, and the lens becomes less convex. If the capsule here is less tight, lax, the lens takes a more convex structure. Now here the lens divides the eye into two cavities. Anterior to the lens, between the cornea and the lens, this is called anterior cavity, and posterior to the lens here is called posterior cavity. Now the anterior cavity has a fluid called aqueous humor, and aqueous humor, its quantity is almost constant. And it is formed continuously. How come it is formed continuously and its quantity is constant? Because it is formed continuously here from the posterior part, from the ciliary processes, and it is reabsorbed from here, which is the canal of Schlemm, into the venous sinus. So it is formed continuously and absorbed continuously. It's like the CSF. It is plasma minus protein. Now this anterior cavity fluid, which is the aqueous humor, سائل الزجاجي, is also divided into two chambers. Anterior to the iris here is called anterior chamber, and posterior to the iris is called, between the iris and the lens, called posterior chamber fluid. And the connection between them is through the pupil. Now this anterior cavity fluid, which is aqueous humor, is important because it gives nutrition to the cornea. You will say that the cornea is avascular. Now, any fluid in a cavity has a pressure. The pressure inside this anterior cavity is called intraocular pressure. This pressure ranges between 12 to 20 millimeter mercury. If this pressure increases more than 20, sometimes more than 30, what depends, this is called glaucoma أو المية الزرقاء. Glaucoma is an increase in the intraocular pressure. An increase in the intraocular pressure here means either there is a block of the absorption here or more formation. Whatever this is, the increase in the intraocular pressure. The posterior cavity fluid here is called vitreous humor. Vitreous humor. And the vitreous humor is formed once in the embryonic life and stays there. Now, the innermost layer, which is very important layer, is the retina, which is the neural layer that has the receptors for vision. The receptors for vision are two types, either rods, because they are rod-like, عصيات, or cones, مخاريط, cone-like structure. So this is very important layer. As you see, this is a neural layer, so it develops from ectoderm, and choroid is a vascular layer, glandular layer comes from mesoderm. So both layers are different from each other, although the retina depends on the choroid for its blood supply. Now, in the cornea here, in the retina, I mean, there is a slight depression here, is called macular lutea, and in the central part of it is called central fovea, that has one kind of receptor that's very important for sharp color vision here. So here the vitreous humor, sometimes it leaks, maybe car accident or whatever, if there is damage to the eye. If it leaks, the retina that is found on its place by the vitreous humors, where the vitreous humors conserves or keeps the structure of the eye on its place here. If this fluid leaks, the retina comes inside the posterior cavity and it separates from the choroid. If it separates from the choroid, it's called retinal detachment, انفصال الشبكية. And retinal detachment is one of the maybe only emergencies in ophthalmology. It has to be fixed back in terms in less than 48 hours or something like that. So this is the structure of the eye. Okay. Look here to the anterior chamber where this is the ciliary processes. This is where the aqueous humor formed and passes through the pupil and it is absorbed through the canal of Schlemm here. This is the cornea. This is the thickness. And absorbed from this canal of Schlemm, it goes to the venous sinuses. You say that the thickness of the cornea is very important. When you say, I want to say to do LASIK or laser, what they do in LASIK, they just cut part of the corneal thickness so as they can correct visual abnormalities. This is the lens, laminated layer of proteins. And this is like بياض البيض. This lens sometimes becomes coagulated, or what we call it like coagulation of the eggs. If they become coagulated, becomes harder. They become harder, like boiling the egg. شو لونه بصير لونه أبيض. And if the lens here is coagulated or denatured, the protein is denatured. If the protein is denatured, it's going to convert to a white color. If it is denatured, convert to white color, it's called cataract, المية البيضاء. If it's going to have cataract, it means that the light will not pass through the lens. In that case, in cataract, you have to replace the lens. Replace the lens by artificial lenses. This is a simple, procedure that takes maybe 15-20 minutes. They replace the lens and that person can see clearly. Now, when we talk about lenses, we have two major types of lenses. This lens is by convex lens, or sometimes we call it converging lens, because as you see here, parallel lights, they converge the light. They collect the light in a point here called focal point. The distance between the center of this lens and the focal point is focal length of this lens. On the other hand, the other lens here is called diverging lens, or concave lens. Here you see parallel lights, they are diverged as if they are coming from a point here on the other side. And this point is the focal point, and the distance between the center is called focal length. As you see here in this one, or this one, the direction of the focal point is different. That's why the first one here, we call it positive lens, and the next one we call it negative lens. Sometimes we have other lenses, they are called spherical lens, cylindrical lens. This is spherical, this is cylindrical lens. Cylindrical lens are multiple of spherical lenses. As you see, parallel light collects here, so cylindrical lens, they don't have focal point, they have focal line. The same principle. Okay, now what is the power of the lens? The power of the lens is, a unit is called diopter. One diopter equals 1 over the focal length in meters. So 1 على 1, 1 over 1 meter equal 1 diopter. If it is more convex, it means the focal length is less, 1 over half a meter, 2 diopters. 1 over 0.1 meter equal 10 diopter. This is the lenses. Now, for lenses here, if the object is here, this is the focal point. But if the light coming not parallel, for instance, is going to be collected here, these are two different points. Now, to focus the image of an object on the retina, we have 4 requirements. The first requirement is refraction of light that's coming from that object before it reaches the retina. What are the medias that this light has to pass before it reaches the retina? We have 4 medias. First media is the cornea. The light has to pass the cornea. If it has to pass through cornea, it's going to refract from air through the cornea, and from cornea pass through the aqueous humor. Also, there is refraction. Then it passes through the lens. It's going to go to fract again, and then through the vitreous humor. So there are 4 medias before it passes to the retina. If you can replace these four medias with one lens, uh, you can calculate the refractive power of that lens to be around 59, or let's say 60 diopters. 60 diopters. So this is called reduced eye. So a reduced eye with 60 diopters, this is the total refraction of these four medias. Now, which one of these four medias contribute the most to these 60 diopters? In fact, the first one that you might uh, not think of it is the cornea. The cornea contributes around 42 diopters of these 60 diopters of all media. That's why cornea is very important. Why when we talk about corneal transplant, why we talk about donation of corneas from people when they die, because corneas are very important for vision, and corneas, they don't have antigenic activity. You can transplant cornea from anybody and give it to anybody. The second requirement for forming an object on the retina is accommodation. What's accommodation? Accommodation is to see clearly from a near or far distances. Uh, we will explain it later. And the third thing is to change the size of the pupil. Meiosis, remember meiosis here is constriction of the pupil, not meiosis is cell division. And mydriasis is dilation of the pupil. Meiosis for near vision, mydriasis for far vision, because meiosis there is too much light when you look to a near object, and there is much less light when you look to a far object. Also, the fourth requirement is convergence and divergence of the eye, because when you look to a far objects, the eye diverge. When you look to a near object, the eye converge. Converge means they are coming closer, medial movement, and divergence is lateral movement of the eye when they are looking to a far object. Why? To have an image formed in and areas in the retina, when they are going to the cerebral cortex, what is formed is one image. You can see one image of any object you are looking for, although there are two images in your eyes, one in the right retina and one in the left retina. But in the cortex, you see it one object. How? Because when they are processed to the cortex, these two images overlap. Now you can try it yourself. You press on your eyes. When you press in your eye and look to any other object, you see two objects. Why? Because you voluntarily interferes with this convergence and divergence. This is what we call it double vision or diplopia, diplopia. Okay, we should not have diplopia. We look like when you look to a microscope by two eyes, you should look carefully to see just one object. We talked about the first requirement, which is light refraction and the power of the lens and what is the contribution. In fact, we talked about the contribution of the cornea as 42, and the lens is very important because normally it varies in children. It can change too much because children, they have more flexible lens. When you become older and older, the protein of the lens becomes denatured or coagulated a little bit by a little bit. By the age of 40, the lens is not flexible, and in that case, what you see, I need to, what glasses? Glasses for what? Glasses for readings. That's why glass for reading around the age of 40, 45, you need it. Why? Because the lens becomes denatured, the lens protein, I mean, and or coagulated. Okay. Now, accommodation, we said that by this mechanism you can see clearly near objects and far objects. How come? If you remember when you have a camera, when you want to have a picture for far objects, you have to change the distance between the lens and the film. When you are going to have a picture for near objects, you also change the distance. This is not a human being. The human being, the distance between the lens and the retina is around 17 millimeter, which is fixed. What you do, you change the convexity of the lens. What we call it, you change the power of the lens. And this is called accommodation. Accommodation for a relaxed lens spherical, when you look too far, the lens is less spherical, more flattened. Why? Because in that case, the ciliary muscles, which are attached to choroid, ciliary muscle, that are attached also to the suspensory ligaments, and the suspensory ligament is attached to the capsule of the lens. The ciliary muscle is relaxed. When the ciliary muscle is relaxed, it goes away laterally. When it goes away, it presses on the C in the suspensory ligament, and it presses on the lens capsule. When you press the lens capsule, the capsule becomes flattened or less convex. Less convex means too far focal length. Too far focal length it means less power of the lens. And this is good for far vision. For near vision, when you want to see to look a near object, the ciliary muscles contract. When the ciliary muscle contract, they become closer anteriorly or medially. In that case, the suspensory ligaments are lax. They are relaxed. If the suspensory ligaments are lax, they have less pressure on the suspensory ligament. So the suspensory ligament, the capsule of the lens takes less flattened, it takes any shape that the lens can take. It means more convex because there is less pressure on the lens because the capsule is lax. In that case, the lens is more convex or fatter يعني ناصحة شوي, more convex. This is good for near vision. So for near vision, the ciliary muscle contract. For far vision, the ciliary muscle relax. So as you see, a relaxed lens is almost spherical in shape. Lens is held in place on suspensory ligaments. Contraction of eye muscle attached to the ligaments pulls the ligaments forward and causes the lens to become fatter, more convex, which is increase its power because you decrease its focal length. This movement to the cilium is under autonomic control. Parasympathetic fibers from the third cranial nerve causes contraction of the ciliary muscle and causes contraction of the iris muscle. The iris muscle consists of two types of muscle. One that's called circular and the other is radial. The circular muscle, they are supplied by parasympathetic, and the circular and the radial, they are supplied by sympathetic. Contraction of the circular causes meiosis or constriction of the pupil, and contraction of the radial causes dilation of the pupil. So Let's see here what we talk about. Fractal, we talk about this. We talk about this. This is the eyeball here. This is the suspensory ligaments. When the people looks to a near object, these ciliary muscle contract, coming closer here. The suspensory ligaments become lax. The capsule of the lens is less stretched. The lens takes more convex. This is good for near vision. For far vision, these ciliary muscles are relaxed. They too are coming farther away. They put too much tension on these suspensory ligaments. Too much tension, they press on the capsule and the lens becomes less convex, flat. This is good for far vision. This is a relaxed eye. Like if you remember my yoga, they think they look as if they are too far. Why? They relax the eye. The eye is relaxed. Okay, so this is the suspensory ligaments here also. And this is the ciliary muscle that is attached to them. And this is the lens in between. Same thing, this is the pupil. This is the ciliary muscle, and this is the lens inside. Look here. This is in case of near vision, the suspensory ligaments here relax. There is less pressure on the capsule of the lens, and the capsule here. I'm sorry. Here, this is sympathetic stimulation. Sympathetic is the relaxation of the ciliary muscle. If the muscle is relaxed here, there is too much tension on the suspensory ligaments. Too much tension, the lens become flattened. This is good for far vision. In case of parasympathetic stimulation, the ciliary muscles contract. The ciliary muscle contract, they have less pressure on the suspensory ligament. The suspensory ligament slackened or lax. Less tension on the suspensory in the capsule of the lens, and the lens becomes more convex or fattier. And this is good for, here is good for near vision, and here is good for far vision. Okay. The third requirement for forming an image on the retina is change in the size of the pupil. The pupil, in case of looking to a near object, is constricted. This is for bright light. This constriction of the circular muscle by the parasympathetic fibers from the third cranial nerve. And when you look to a far object, there is too much light coming, so you increase the size of the pupil to make the lines too much light. This is contraction of the radial muscle by, this is called mydriasis, and this is called meiosis, and this is the normal light. Now the fourth requirement for making an image on the retina is convergence and divergence of the eye. Convergence for near vision and divergence so as the image is formed on both retinas and areas on the retinas that when they come to the cortex, they just see just only one image. Now, what we said last time is when the lens is become, the lens protein become denatured, coagulated, it's no more going to change its convexity, and this is called presbyopia, ضعف العين, inability to accommodate. And in that case, that you cannot change the convexity, the convexity is fixed. by the age of 40 to 50, that person, his lens is denatured protein, and he needs glasses. For what? For reading. Now, what are the abnormalities of refraction? There are two abnormalities of refraction: farsightedness or hypermetropia, and nearsightedness, myopia. طول النظر farsightedness, and قصر النظر nearsightedness. Normal eye is called emetropia. Emetropic eye, which means that vision for near or far objects, the image occurs on the retina. In certain cases, the distance between the lens and the retina is shorter than normal, less than normal. So parallel lights here, its image is formed behind the retina. This is called farsightedness. So how you want to bring this image here from behind the retina anteriorly? You can bring it anterior if you change the convexity of the lens. You make it more convex. You bring it a little bit anterior. So far-sighted people with some accommodation here can form an image for a far object on the retina. So in fact, these people, they started accommodation earlier than normal people. So by the time they reach a distance, maybe 40 centimeters, this is the maximum limit of accommodation. This distance between this point, say 40 centimeter, and the eye is called the near point for that person. Near point for normal, maybe, let's just don't quote me for numbers, maybe 30 centimeters. Near point for far-sighted people is 40 centimeters or 50 centimeters. It depends on how far-sighted people are. So in that case, those people, they tell you that I can see clearly from too far, but when they are going to bring their book closer to their eye, they don't see clearly. They have to bring the book further than the normal people, further than they used to, whatever, if they are becoming farsighted later on. So the near point, the distance between the lens here and the point that they can see clearly is further than normal. Now the myopic persons, the distance between the lens and the retina is more than normal. They are more than normal. Parallel lights from two far objects, its image is formed in front of the retina. If it is in front, they can see clearly too. This, like here, they can see far, and here they can see. But in this case, they cannot be corrected. They cannot correct it by changing the convexity of the lens, because this is the least convex lens. They cannot go beyond that. And if you change the convexity, in fact, you bring it closer and closer. So the only way you can correct myopia is to wear glasses that diverge the light rays, and they end in forming an image of the retina. Here, to have these people hyperopic or hypermetropic appearance more relaxed, instead of pressing a little bit on the eye, they can wear biconvex glasses, and then the near point become normal. Here, those people, the near point is closer than normal, because when they are looking too little into a near object, their near point is they don't see clearly from too far. They have to bring these objects further near to them to see clearly. So their near point that they can have more ability to accommodate here is less than normal. If it is 30 in the normal, 40 in myopic, and in the myopic it is maybe 20. So this is the difference between them. Okay. Now this is how they are corrected. This is myopic person. You correct it by concave diverging lens, and this is correction of hyperopic person by convex. We said hyperopic, they can see clearly from too far without any problem with some accommodation, but the problem is their near bond. They can't see clearly, they can't read the book from 30 centimeters. They have to bring it further 40 to see. That's why بقول لك انا بشوف من بعيد ما بشوف من قريب. بس هون القريب بقول لك انا بشوف من قريب لانه near point is less than normal. Okay. So this is the error of diffraction. This is emmetropic eye normal, and this is nearsighted people. Nearsighted people, in fact, here as you see, nearsighted eye uncorrected image occurs in front of the retina. If they are corrected by concave, the image is formed in the retina. Far-sighted people, they can have they can be forming the image on the retina with some accommodation, but to be more relaxed, more quiet, they wear biconvex glasses. Okay. The same thing here. This is accommodation, normal eye. Normal people can see clearly from far or near object by certain accommodation, what we said about. This is nearsightedness. Nearsightedness, when they look to a near object, they can see clearly because they bring the object further back. Okay? So this is their near point here is less than normal. As you see here, this is near point, this near point. But they can be corrected and bring the near point a little bit further around like the normal by convex. No accommodation here. Accommodation or certain accommodation depends. Okay, the far-sighted people here, they can see clearly with some accommodation as you see here, without glasses. So their near point is further than normal. But to be relaxed, they can wear glasses. This is glasses is biconvex glasses, biconvex with less accommodation. As you look to the convexity of the lens, if there is no accommodation, it means that the lens is flat. There is accommodation, the lens is more convex. The lens is more convex. Okay, more convex here. Okay, there are other errors of vision. One's called astigmatism. Astigmatism, you see the cornea is multiple spherical lenses. And multiple spherical lenses, like what we said about cylindrical lenses, they don't have focal point. They have focal line. Normally, these cornea, its planes, if they are normal, its planes, they are intersecting in one point, as if in the end they have one focal point. But sometimes there is one of the planes is not going to be synchronous with the other planes, that this plane has a focal line that does not intersect with not the same point that other planes intersect, which means that there is one plane and there is another planes. In that case, it's called astigmatism. يقول لك والله عندي انحراف. How you correct it? You correct it also by cylindrical lenses. How we correct it by trial and error. If you go to the opticians بتروح على تبع النظارات بيجرب لك تجريب. بجرب يقول لك هاي العدسة أحسن هاي العدسة أحسن. هو what he did, he does just change the planes of the cylindrical lens. to correct the plane that is abnormal. Cataract حكينا إنه الكاتاراكت إنه the lens becomes denatured protein of events أو coagulated. بتبطل, it's not going to change its convexity, and this is called المية البيضاء. The treatment is to change the lens by artificial lens. Now, abnormality or in visual acuity. What is visual acuity? Visual acuity, the distance between the lens, this is the lens say, and the retina here is 17 millimeter. This is called 2 points discrimination. يعني to determine the 2 points here as 2 points. If you want to determine 2 points as 2 points, if you remember from last year, they should hit 2 receptors. If this is one receptor and this is different receptor, we can determine that this point is different. Like here, say, look here. This is like 6 meters, whatever that meters. If this point and this point are determined as 2 points, this letter we can read it C. But if this point and this point are not determined as 2 points, then the 1 point we just read it O. Now, if we want to read it C, this point and this point, you see this is the light rays from these points hit there, and they hit one receptor here, one receptor. If they hit 2 receptors, in fact, we will determine this point different than this point and we'll read it as C. Now, normally, let's say, the angle they form here is 1 minute. Sure, 1 minute. And the angle is 360 degrees. Each degree consists of 60 minutes. Each minute is 60 seconds. So this is 1 minute. As you see, this light goes on مثلا on 60 meters, on 12 meters, 24 meters. بتضلها الانجل نفسها بس تزداد. The distance between these 2 points are increased. So a normal person, it is calculated from these receptors, the distance between 2 receptors, which is around 2 micrometer, because the diameter of one of these receptors is 1 micrometer. If the distance between these 2 receptors is 2 micrometer, then forming an angle 1 meter, then the person can see clearly. هاي على هون البعد 6 متر، على هون البعد 12 متر. شوف طلع عليها كلها، اللايت كله وين ما راح الانجل نفسها. This person, we call it that his acuity is 6/6 because he is forming an angle. طيب, if there is another person, this person can see it clearly at 12 meters. بس هذا البيرسون ما كان يشوفها على 12. We have to bring it to 6 meters. زي مثلا هون to 6 meters until he can see it clear. شوف لما قربناها لهون راح يسوي زاوية أكبر. It's going to form bigger angle. ليش؟ عشان to hit 2 receptors a little bit further than normal. ليش؟ لأنه the density of the receptors in his retina is less. عشان هيك ما بيشوفهم clearly إلا if he is not going to see these 2 clearly like this one unless you bring it near to this person. So in this case, if the person can see it at 12, but the abnormal person, you have to bring it to 6 meters to see it, we will say that this person visual acuity is 6/12. But is a normal person can see it at 24. بس الابنورمال بدك تقربه على 6 meters عشان يشوفه clear. ليش؟ to form a bigger angle even. bigger angle. ليش؟ لأنه density of receptor عددهم هون قليل على الريتنا. بنقول والله نظره his vision is 6/24. So 6/12, 6 is the ability to see letters of a given size 6 meters. This is normal. 6/12, normal person can see it at 12. The abnormal, you have to bring it to 6 to see it. 6 over 60, normal can see it as 60. But the abnormal, you have to bring it to 6 meters to see it clearly. You see, this is in our system, we measure by meters. In the American system, they measure by feet. They say 20 over 20, and 20 feet over 12, تقريبا 20 feet, around 60 meters. So 20 over 20, 20 over 40, 20 over 24, whatever. This is multiplication of 20. So this is what we call it the visual acuity. So don't remember that abnormalities in refraction are different than abnormalities in acuity. They might be corrected by the same lenses. So 6 over 12. That's how you can correct 6 over 12. نفس الشيء. You can correct it by diverging lens. Diverging lens. يعني اللي نظره 6 أو 12 أو 6 أو 60 correction by diverging lens. Diverging حكينا diverging يعني البايكونكيف. بايكونكيف سميناها negative lens والبايكونفكس positive lens. لما تحكي negative تقول والله أنا عندي نظارتي ناقص 2 ناقص 2 دير بالك. It's not degrees, it's diopters, minus 2 diopters, which means that the focal length of this lens is half a meter, but it is biconcave, it is minus. If it is plus, it is biconvex, okay? This is the charts that can be, this is called Snelling chart. The same mechanism, whether this is the ease, where is, like when مفتوحة يمين شمال, where it's open up, left, right, whatever. And this is the lights here, 60. The same thing here, letters. Nowadays in children, they use pictures, cars, flowers, whatever. But the same, they use the same principle, that the distance between two arms of the picture, two arms of the E here, two arms of the letters here, is going to form an angle when it reaches the lens. The angle normally should be 1 minute, if it's less, or less. 1 minute or more, it means there is abnormality in visual acuity. Okay. Now, we talked about the intraocular fluid. The intraocular fluid that's found in the anterior chamber, حكينا, its quantity is almost fixed. It is formed in the ciliary body, and it is absorbed in the canal of Schlemm in the anterior chamber. حكينا sometimes there is increase in the fluid either due to decrease in the absorption or increase in the formation. This is called glaucoma. Glaucoma. Now the vitreous humor that's behind the lens in the posterior cavity, حكينا, it's formed once. And unfortunately, if it leaks sometimes, the retina becomes detaches, يعني انفصلت. Detachment اللي فيها هي receptors. Receptors معناته انفصلوا عن مين؟ They are detached from the choroid, which is the vascular that supplies the retina with the blood. If they don't have a blood supply, they will degenerate. If the receptor degenerate, that person become blind. So that's why they have to be corrected, fixed within 48 hours. Okay. This is the lens, this is vitreous humor, this is the aqueous humor, as you see from the posterior chamber and absorbed in the anterior chamber of the eye. This is the structure. This is the same we see. This is the vitreous, this is the ciliary body formed here, and we had the aqueous humor حكينا إنه it's like the CSF. It is plasma minus protein, and it is important. It gives nutrition to the cornea, since the cornea is avascular, okay, and it keeps the structure here normally. If it increases above 20, this is called glaucoma here. So the aqueous humor, whatever formation, 2 to 3 milliliter, we don't like you to remember what we told. So if there is block either through the canal shrimps, or there is more formation, this is going to cause what we call the glaucoma, increase in the intraocular pressure above 20 millimeter mercury. And there is special machine that measures the intraocular pressure، بحطوه على الكورنيا، بيفحص ضغط العين، بيقول لك ضغط العين زايد أو ضغط العين ناقص. Glaucoma, if it stays like this, it might cause compression on the optic nerve and cause blindness. So that's why بيشعروا هدول عندهم increase intraocular pressure, very severe headache sometimes. Okay. Okay, thank you very much.